Today's lesson is all about degrees and angles and radians. So starting out, I want you to just think about the coordinate plane and then think about a circle on that coordinate plane. All the way around the circle is 360 degrees. So if you think about starting at 0 degrees, when you go all the way around, it's also 360 degrees. So at the starting point is both 0 and 360. So if we are going this way, around, so halfway around is 180 degrees, and then this would be 90 degrees, 270 degrees. So when you have an angle, here's going to be the initial side, and then let's just say we have an angle here, so this is opening from here to here. So here on the x-axis is your initial side, and then this is called the terminal side. So if we're just going to sketch two angles, so here starting at the initial side, so 200 is going to go just past the 180. So notice how when it's a positive angle, we are going counterclockwise. So now when we have a negative angle, we'll be going clockwise. So 270 degrees is the same as negative 90. This could be negative 180, negative 270. So if we're starting here still, we're going to go this way. So 300 would be just past that negative 270. So here's just the basics of graphing different angles. And now we're going to look at how what a radian is and its relationship to angles. So here on a coordinate plane, I actually drew a circle to kind of give you a visual. Radians have to do with circumference around a circle. So circumference, that's just perimeter of a circle. Circumference is diameter times pi. So the idea is if the radius is 1, a unit circle, the circumference is 2 pi. So all the way around the circle, instead of 360 degrees, all the way around is 2 pi. And halfway around is pi. And then half of that would be pi over 2. And this would be 3 pi over 2. So let's just think about here. I mean, you can probably just visualize what the radian is, but I want to think about it in degrees. That's 45 degrees. So 45 degrees is how much of the circumference of that circle. Well, 45 degrees is a part out of the whole circle, 360 degrees. So then the entire circumference is 2 pi. So it's 45 out of 360 times 2 pi, which if you multiply that through, you will get pi over 4, which makes sense because this is halfway between pi over 2 and 0, which would be pi over 4. So there's just the intro to understanding degrees and radians on a circle. So we will be converting back and forth between degrees and radians. So here are the shortcut formulas. So if we have 120 degrees and we want to know its equivalent radian measure, we'll just do 120 times pi over 180. So then it's really just simplifying here. So we can cross those zeros out, divide them both by 6. So 2 pi over 3. So 120 degrees will be at the same location as 2 pi over 3. So that angle measure, 120, matches up with the radian, 2 pi over 3. Okay, let's convert the other way. So now if I give you a radian, let's say 5 pi over 6, and we want to convert it back to a degree, we will multiply by 180 over pi. The pi's will cancel. I can cross simplify there, so I'll have 5 times 30, which is 150 degrees. So 150 degrees will be the same location as the 5 pi over 6. Okay, so the next part, coterminal angles. So I'm going to draw an angle. So remember, so this is the terminal side. Coterminal is basically they're sharing this terminal. So how many different angles can share that terminal? Well, this is, let's say that is 135 degrees. Well, what's another angle that's going to share that terminal? We could go backwards this way, and then it would be negative. It would be negative 225 degrees. Or you could even go around, all the way around, and keep going and then stop, which would be 495 degrees. So there's an infinite amount of angles that will share that terminal side, coterminal. So whatever angle measure you have plus 360 n times kind of represents that infinite amount of angle measures that would share that terminal side. So let's do the same idea except with a radian. So going the opposite direction, but ending up here, that is the same as negative 5 pi over 3. So just like the degrees, there's an infinite amount of possibilities of radian measures that share that terminal side. So if you take the radian measure plus 2 pi n times, an infinite amount. Okay, so a degree measure, 45 degrees. Let's find some coterminal angles. You can literally just add 360 multiple times. You can subtract 360. So for 45 degrees, if you add 360, would be at 405 degrees. You can add 360 again, which would be 765 degrees. Starting at the original, we could also subtract. I shouldn't be writing equal signs. They're not an equal measure, I guess. They're just at the same location. So all of these angle measures are coterminal. Okay, so then when you have the radians, you can add 2 pi multiple times. You can subtract 2 pi. So negative pi over 6, if you're going to add 2 pi, just get a common denominator. So negative pi over 6 plus 12 pi over 6, so that is 11 pi over 6. So you can take that negative pi over 6 and you can subtract the 2 pi, or 12 pi over 6. So you'd be at negative 13 pi over 6. So these three would all be coterminal. Okay, and now the last part is reference angles, which can be defined as, so it's the smallest angle made between your terminal side and the x-axis. So here I've just drawn an angle. So here we have the terminal side. So now we're looking at taking that terminal side and just connect it to the x-axis at 90 degrees. And then the reference angle is just, what is this angle right there? We're going back to that idea of angles inside a right triangle. And finding the reference angles, how you find them is different depending on which quadrant you are in. And a reference angle can be noted as theta prime. If you are in quadrant 1, your reference angle is just equal to your angle measure. But in quadrants 2, 3, and 4, it changes a little bit. So for this part of the lesson, I'm just going to stick with degrees for the video. In class, we'll practice with radians as well. But let's just look at quadrant 2, 135 degrees, which would be right there. So here's that angle measure. But now take the terminal side, and we're going to connect it down to the x-axis to make a right angle. We want to know what is that angle right there. So to do that, we would just do 180 minus our angle measure. So to find the reference angle, it's just 180 minus 135. If we were doing radians, it would just be pi minus theta. So you're going to do this formula anytime you're in quadrant 2. So our reference angle is 180 minus 135, which is 45 degrees. So this angle right there is 45 degrees. Okay, so now 200 degrees. Let's go here. So you take that terminal side and connect to the x-axis at a right angle. We want to know, this is our reference angle right there. So if you're in quadrant 3, to find the reference angle, this time we go the other way. So we have our angle minus 180. Or if you're doing radians, it's our angle minus pi. So in this case, our reference angle is 200 minus 180, which is 20 degrees. So 300 degrees would be, just estimating here. So it's going all the way around. But then the reference angle is if you take the terminal side, connect it to the x-axis. What is this angle here? So a lot of these, they're kind of obvious, but we still have these little formulas. To find the reference angle when you're in quadrant 4, the reference angle is 360 minus your angle. Or if you're in radians, 2 pi minus your angle. So in this case, the reference angle is 360 minus 300, which is 60 degrees. Okay, so practicing these each one more time, but this time some angles that maybe are a little tougher. So negative 240, all that means is you're going the other direction, 240. So we're in quadrant 2, so these correspond. So we're doing this formula right here. So if you go here, right angle, what we really want is, what is that angle measure right there? However, when we're doing this, we want a positive coterminal angle. So negative 240 to find the coterminal angle, let's just add 360. And when you do that, you get 120 degrees. So going here is 120. So now doing the formula, the quadrant 2 formula, the reference angle is 180 minus 120, which is 60 degrees. Okay, so negative 150 going this way. If you cut to the x-axis, what we want to find is this angle right here. So let's get the coterminal side. So we want to do negative 150 plus 360. So that's 210 degrees. So that means going this way is 210. And now, because we are in quadrant 3, we're going to use to find our reference angle. It is 210 minus 180, which is 30 degrees. Okay, 650 degrees. Let's find a coterminal. So let's do 650 minus 360, and that will be 290 degrees. So 290 is going to go around past 270 a little bit. So we want this angle right there. So using this formula, our reference angle, because we're in quadrant 4, is 360 minus 290, which is 70 degrees. So these are the reference angles. So a lot was going on in this video. Angles and radians, coterminal, reference angles, all of it building to the unit circle. Good luck with your lesson.